How to rationalize irrational numbers. Now, have you ever gone on your calculator when you're working with our numerical system and you go 1 divided by 3? What do you get? 0.333 repeating. Right? Now, working within our numerical system that we have right now, basically we're working within tens, a base 10 system. 3 does not go into 10. It doesn't go into 100. It doesn't go into 1,000, right? So when 1 equals 100% and 1 over 3 equals 0.333 repeating, 1 over 3 multiplied by 3 equals 1. However, 0.333 repeating multiplied by 3 actually equals 0.999 repeating, which is wrong. It's not actually the answer. This is the answer. Basically what's going on is 3 doesn't go into 100, which is equal to the 1, being the whole number. Thus, it's unable to use this numerical system to represent, for example, an irrational like a third, 1 over 3. Now, obviously, your calculator would just round up 0.99 repeating to the 1, but when you start doing 1 over 3 multiplied by 1 over 3 multiplied by 1 over 3, eventually you start working with irrationals. The more that you work with a numerical system that is not able to define a fraction like 1 over 3 as an absolute definitive, the more you work with this system that has these irrationals in place, the more you employ them within your mathematical equations, the more flawed your answer becomes and the further it becomes from the actual truth of what it is. Now, how can we help resolve this? First, we can start looking at factors. Now, we understand that 3 would go into 6 twice. But obviously, that's a lot lower than 100. So really, not that great of a total percentage. However, we also know that 3 would then go into 60 20 times. But that's still lower than 100. We can then have 3 going into 120 40 times. And when 120%, for example, would be the 120% that would equal 1, therefore, 1 over 3 would then equal 0.0.4.0. Now, why am I creating these extra decimals? It's because normally this number right here being 0, then 0.0, the reason this becomes the point and then the point is because this can go to 0.1.1.9, and that would still not equal 1, because it would have to have 1 more to allow it to do so. Now, the lowest number that has factors, meaning numbers that go into it, from 1 through 10, is 2,520. So for example, when we're working with 2,520 and 2,520 becomes the total percentage that would equal the whole number being the 1, then if 2,520 is divided by 3, we get 840, which means once again 1 over 3 can be represented, right? Because 840 is equal to 1 over 3, and 840 times 3 equals 2,520. 4 goes into it, 5 goes into it. We know that because it ends in a 0. 6 goes into it. But let's work with another irrational fraction, 1 over 7. If we take 1 over 7 and then we understand this as a percentage of 2,520% amounting to the 1 being the whole number, we can then understand that 1 over 7 can be represented as 0.0.3.6.0. Now, you have to take into consideration that math, our numerical system, is an abstract concept invented by man, which means the way that it is not the way it has to be. It is our way that we conceive of these numbers that we have created them for a communication between ourselves. But the way that they are is still an abstract concept. And when we're working with fractions that are not represented by the numerical system that we use as them arriving as irrationals that we cannot define as an absolute definitive, we can then understand that we can then create a alternative conceptual idea of how these numbers can be represented as an absolute definitive. So we have the first decimal here. Then we have the second, the third, and the fourth decimal. If we know that 360 times 7 would equal 2,520, therefore 1 over 7 is now going into 2,520 as a percentage that equals 1. Thus now 1 over 7, a currently irrational number within our current numerical system, when we understand that we can simply change our numerical system to rationalize an irrational number in our system, we can then understand that numbers are not just the way that they are, because it is an abstract concept that we can simply amend in order for us to allow us to rationalize what there is. So when we have 0.0.3.6.0, the reason for this is because these first three numbers can certainly all go to the 9 before this number then becomes 1. But when this number becomes 2, it will never go above 2. The reason for that is we are now making 2,520% the total percentage that allows us to have a percentage that accounts for the whole number 1. But we incorporate all these extra decimals with the understanding that this number would not go above 2. This number can certainly go up to 9, but then this number would only have to be 1. And when this number is 2, this second decimal now would never go above 5. Now, this third decimal can certainly go up to 9, but when this decimal is 2 and this decimal is 5, this third decimal would never go above 2. And this decimal certainly would go 0 through 9, but when this decimal is 2, this decimal is 5, this decimal is 2, it would never be any number but 0. Therefore, we can allow ourselves to understand how to rationalize the irrational system that we have in place and actually have an absolute definitive number that is the actual number that allows us to understand how to represent these irrational numbers that we have in our numerical system and to rationalize them so that we have something to work with that is not the wrong answer, but is an absolutely defined answer for exactly what it is. Now let's just take 9 for example, right? Well, let's take 2,520. And then let's just say we divided that by 9. Now I'm just going to cheat and use a calculator here. Yeah, my brain is a little bit overworked these days. My brain's been complaining about everything I've been doing, so I'm trying to listen to it and give it a little bit of a break. Okay, so we get 280. Okay, so then what we do is then we understand that 1 over 9 is equal to 0.2.8.0, as 280 multiplied by 9 equals 2520. Thus 1 over 9 would then be multiplied by 9, having an absolute definitive number to work with that would actually result in 1. The answer. Now, eventually you're going to realize that if this 2,520 percentage, and then all of a sudden you're working with a prime number, and you realize that you're now working with a fraction of 1 over 11. And as 11 does not go into 2,520, what do you do? Well, if you take 2,520 and you multiply that by 11, then you would know that 11 would go into this number that is being multiplied by 11. 1 times 0, 0, 2. It's pretty simple, really. Drop the 0 to 5. Whoops. Oh, this is my bad. 0. Yeah. 2, 5, 2. 0, 2, 7, 7, 2. So what do we have? 27,720. Now, why did we do this? It's because when we have a mathematical equation that is working with 1 over 11, and our total percentage is 2,520, no, that's not going to work. But when our new percentage now becomes 1 equals 27,720%, then 11, 1 over 11, going into 27,720 as a percentage, now 1 over 11 is represented as 0 decimal 0 decimal 2 decimal 5 decimal 2 decimal 0. Now you're coming into the understanding here that you can simply additively add more decimals with the understanding that whatever the total percentage is that would amount to the total, you would never surpass that with the understanding that this is the new percentage that equals the whole number being number 1. And as 1 over 11 can now be represented as this, 0 decimal 0 decimal 2 decimal 5 decimal 2 decimal 0, well, now you can actually represent 1 over 11 as something that becomes rationalized. Now eventually you're going to run to the situation, you're going to say, hey man, I'm running into another prime number that I can't represent. I hear you. Now you're working with 1 over 23, right? and you're working with the 1 over 11, you've got the 1 over the 23, you realize, oh boy, it's not really going to work, right? What do? 27,720, you multiply that by 23. 0, 6, 21, 21, 23, 2, 6, do the 8s, drop the 0, repeat. Wait, no, 2 times 0, 0, 2 times 2, 4, 14, the 1, 2 times 7, 14, making 15, the 1, 2 times 2, 4, 2, the 5. You add, you get the 0, you get the 6, the 5, 7, 13, drop the 1, 2, the 6, and now you've got 637,560. Now you understand that 23 goes into this number because 27,720 multiplied by 23 goes into, yes, so therefore 23 goes into this number. Now if you know that 11 goes into 27,720, and you know that all the numbers before would go into 2,520, and you're working within these fractions, yes, you can then start solving for all these irrational problems that you have that currently are a number that you're actually not getting the real answer for. Now you also have to understand that the more that you're working with numbers like 1 over 23 multiplied by 1 over 11 multiplied by 1 over 41, a bunch of prime numbers, you're going to have to come to the understanding, let's say I even add some more, right? It's always wise to start with the 2520 and then work your way up to work with the other fractions that are unrepresentable. Therefore, we know 7 goes in 2520. We then multiply that by 11. We then multiply that by 23 and then multiply that answer by 41. Now you're going to come into the understanding as well that when you start repeating over and over certain fractions, it's not quite going to work the way it's working before, because the more you work with an unrepresentable fraction that simply goes into a number that you were working with, you're then going to have to multiply that number multiple times over for it to be represented. So when I have 1 over 23, 1 over 23, 1 over 23, for me to be able to do this, I know that I can start with the 637,560 as the total percentage, but then I'm doing 1 over 23 again. So it's then best for me to multiply that by 23, getting an answer, and multiplying that by 23, getting the answer, and now making that my total percentage, understanding that when I have 1 over 23 fractions that I am working with within my mathematical equation, I know that they will then be able to successfully go into this total percentage, so I will have an absolute definitive number for something like this that I could potentially, or anybody could potentially be working with when they are trying to work with a mathematical equation with irrational numbers. Now, when you take this into consideration, you will realize that when you are able to amend the mathematical numerical system in terms of the total percentage value that would equal the 1, things that are currently irrational are only irrational because we are working within a numerical system that is not able to define them within their true nature of how they are truly represented. That doesn't mean, though, that they are irrational. It is simply the irrational numerical system that is irrational, not the number itself, as clearly it can be rationalized. There you go. Something interesting is there is a potential fraction that you can see that is a potential abstract concept, not actually true to nature, but in its efforts to represent pi, as 22 over 7 is pi. Now, again, this is not actually the real fraction that would equal pi, but when we are working with something like this, as we know 7 goes into 21 3 times, well, then we have our 3. But if 1 over 7, when we understand that we're working within the 2,520 percentage, that's right, 0 decimal 3 decimal 6 decimal 0 is 1 over 7. Because when 360 is multiplied by 7, that's right, it's 2,520. Therefore, when I understand that pi would start with the 3, and when I'm left with this 7 here, would be, again, therefore 3, 1 over 7 equals pi. If I'm only remaining with really the 1 over the 7 that I can't represent, but I amend the system with the understanding that 2,520 becomes the total percentage that equals 1, then 0 decimal 0 decimal 3 decimal 6 decimal 0 allows me to represent my remaining fraction as an absolute definitive number. Therefore, pi becomes 22 over 7. Again, that's not actually what pi is, but again, we're simply talking right now about rationalizing irrationals. Therefore, in that equation, pi would then equal 3 decimal 0 decimal 3 decimal 6 decimal 0. And you see that this is not a repeating number. This is not a number that never ends. This is not a number that has no pattern. It is an absolute definitive. Thus, we start working with something that is concrete. And the beauty of this is when we are able to also amend our units of measurement for a circle with the diameter and the circumference, it becomes really quite simple. Now, I don't really have the tools around to do it myself, but basically, here's your circle, right? I know, it's kind of like ghetto. You can measure the diameter. Now, you can understand that you don't have to use the imperial system of measurements, and you don't actually have to use the metric. You can simply amend it and make up your own units of measurement. So then if you do calculate the diameter and you get the measurement from that, you would then cut this and level it out. That would give you your circumference. Now, when you start working with those measurements, eventually you're going to end up with a fraction, like maybe 1 over 23 or 1 over 7 or something of the sort, that you'll realize that will not be able to be defined. But when you can understand all this, you will be able to define it. As I already know what pi is. But really, if I tell you guys how to do everything, then I'm not giving you the spark to ignite the fire to allow you guys to understand that you will learn more when you learn and start doing it yourself. The other thing that can be done after this is when you understand how you could program a calculator with the understanding of an algorithm that would be able to amend the numerical system in order to take irrational numbers and have them be rationalized with the understanding how to take all the equations that all the irrational numbers that you're working with within a mathematical equation or a formula. And you can then program the calculator with the understanding of how to amend the decimal system in order to have these irrational numbers become rationalized. And then computers will be able to compute these kinds of things. Because it's not the computer's fault that it's not able to represent these things. It simply doesn't have the right numerical system to be working with to get it done. But it can be.